All right, so this is going to be the first of many lessons involving transformations. And the first type of transformation we're going to look at today is a vertical translation. In order to describe what happens in a vertical translation, I want to take you back to your 20-1 days. Do you remember this function, y is equal to x minus p squared plus q? Do you remember that quadratic? Well, I hope you do, because we drilled and killed you on that. That is a quadratic function in vertex form. P and Q gave you the coordinates of your vertex. So yes, this was a 20-1 concept, but we're not in 20-1 anymore. You're in 30-1. So we're going to take that familiar concept and now apply it to 30-1. All right. So the first thing I want to do is I want to point out there's going to be a couple differences from 20-1. Okay, so the first difference is has to do with the variables. So a couple of our variables from 20-1 are now changed. This p is now referred to as h, and this q is now referred to as k. So what happens is now your function looks like this: y is equal to a times x minus h squared plus k. All right, so big whoop-de-doo. We changed a couple variables, but does it affect what you've learned in 20-1? No, it doesn't. It just changes the equation. It just changes the look of it anyways. All right, so going back to 20-1, think about this graph. Y is equal to x squared. What did it look like? Well, that is a parabola, and it opened up just like this, and it had a vertex right at 0, 0. Okay, so here's another question for you. What happened when we graphed y is equal to x squared plus 3? Okay, when we added the 3 to the x squared, what did it do to the graph? What did it do to it? Well, that plus 3 corresponds to the q value from your quadratic function in 20-1. And remember, like I said, the q value is the y coordinate of your vertex. So the original vertex was 0, 0. When you added a 3 just outside of the function, what happens to your vertex? It became 0, 3. So what happens is that your vertex moves up 1, 2, 3 units. Okay, so there's a vertex. Did it change the shape of the graph? No, it didn't change the shape of the graph. It still opened up just like this. All right, so what did we just do to the original graph? Well, we just move it up. That's what a vertical translation is. It's a vertical translation upwards. So you were applying vertical translations in grade 11. We just didn't call it that. We just called it change a q to this value. But all the while, you were vertically translating your parabola. But remember, in 30-1, it's not called q anymore. It's called the k value. All right? So that is the first difference between 20-1 and 30-1. The second difference also has to do with the equation. This positive k is no longer going to be all by itself anymore. What's going to happen is that in 30-1, it's going to be subtracted from both sides so that the k comes to the other side of the equation. So it's going to look just like this. So k has moved to the left-hand side. But remember, does it change what you know from 20-1 with respect to the graph? No, it doesn't. It just changes the look. These two equations are exactly the same. Okay? All it is that now this k value is on this side, and just notice these look very similar, doesn't it? Okay, so we have a minus sign now. That's the difference right there. Okay, so let's go to the next slide. I'm going to introduce a common 30-1 question, and it might look something like this. A 30-1 question might look similar to this anyway. So it could be, could you describe to me what the graph of y plus 4 equal to x squared looks like when you compare it to y is equal to x squared? What are the differences between this graph and this graph? All right, so remember, this is the 30-1 form. See how this y value is no longer alone by itself on the left-hand side. Well, if you want to see what happens to the graph, bring it back to your 20-1 roots. Bring that 4 over to the other side. Okay, so we have y is equal to x squared minus 4. Does that look a little bit more familiar to you? Well, I sure hope so. It means that we have a k value, or it used to be called q now, but we call it k. My k value is going to be negative 4. Okay? So what happens when k is negative, in fact negative 4? Well, go back to the original function. Y is equal to x squared. Okay, so there's the original function. When we graphed that function, what happened to the graph? Well, remember, since this used to be called q, that was the y-coordinate of your vertex. So remember, the vertex of the original graph was 0, 0. Now it's going to become 0, negative 4. All right, so your vertex is moving down 1, 2, 3, 4 units. And does it change the shape of the graph when you move it down? No, it doesn't. It still keeps the same shape. It's still opening upwards just like that, but now it's vertically translated down. Okay, so what can we conclude here? When k is less than 0, your graph moved down. Okay, let's go back to the other side. When k, which was right over here, when k was greater than 0, you moved upwards. So that's the general case right there. When you have a graph, y minus k is equal to f of x, okay, that's 30-1 right there. If you have a function that looks like that, where you have a k value, that means you have a vertical translation happening. And there are two types of vertical translations. The first type is where k is greater than 0. This means your graph is moving up k units. The second case is where, you guessed it, k is less than 0. So the graph is moving down the absolute value of k units. Now, the reason why it's the absolute value, you can't move negative units anywhere, so you have to take the absolute value, so you're only working with positive numbers. Okay, so you can apply a vertical translation on any type of function. That's why it's generalized as f of x. So it could be a cubic, could be quartic, could be quintic. Doesn't matter. As long as it's a function, you could still apply the vertical translations. And remember, that all has to do with the k value. And that is my introduction on vertical translations.